Hello everyone, welcome back. This is Captain Viveksheel Srivastav, and today the topic that we are going to cover is construction of Mercator charts. So in the last video we had talked about the concepts behind the development of Mercator charts. What are the problems that we face while navigating on the globe, and what is the need for transferring all the data to a paper chart. Okay, so last video we understood how to do it, and today we'll go about the calculations, how to construct a Mercator chart given the data that you have. Okay, so I'll just refresh last time whatever we did, a little bit of this. So last time we tried to depict a 46 miles by 46 miles piece of land at 40 degrees north latitude. We tried to develop a chart of this area, and what we got was there was a east-west and a north-south distortion when we transferred that data to a paper chart, and we have discussed the reasons for those distortions in the last video. And if you remember, now this is the delat and this was the departure, all right, and our longitude scale was 1 minute of longitude was 1 centimeter, if I remember. Yeah, so okay, and the d long between these two meridians was 1 degrees. So d long was 60 minutes. So when we made the meridians parallel, what happened was the d long is of course it's same all throughout. So d long was still 60 minutes. But what happened to the departure? The departure, which was here 46 centimeters, had become 60 centimeters over here. But the actual departure is still 46 miles. Cannot be 60. It is 46. And over here, the delat, that is also expanded. This has also become 60 centimeters, right? Because we had an east-west distortion and then a north-south introduced north-south distortion, because of which this 46 by 46 square became a 60 by 60 square. So now this, as we have seen last time, this was denoted by DMP, difference in meridional parts. So basically this gives you the distortion, the north-south distortion that has happened. Okay. Now here our d long longitude scale was still 1 minute is 1 centimeter. So if I depict 60 minutes over here, I will make 60 lines. Each one of this unit is 1 centimeter, right? Now this distance on the chart is 60 centimeters. This is also 60 centimeters. So last time we had seen that we had to modify our latitude scale so that we can read 60 centimeters as 46 miles. So our latitude scale was 1 minute of latitude was equal to 1.3 centimeters. That is what we had reached to, right? So what happens is, although this is 60 centimeters, but this is only occupying 46 minutes of latitude. So from here, if this was suppose 40 degrees north, this is 40 degrees 46 minutes north, although it is 60 centimeter. But now the distance between each 1 minute, the gap is 1.3 centimeters. Here, this is 1.3 centimeters. All right. So on the chart, this is 60 centimeters, this is 60 centimeters, and we have elongated our latitude scale so that we can read that 60 as 46 minutes. Now what happens with departure? You see, departure is actually 46 miles. Departure is departure. It is the east-west distance, and it will remain same whether you measure it on a globe or you measure it on a paper chart. The departure is 46 miles at 40 north latitude. It has to be 46 miles. So the departure, if you measure the distance between these two meridians on the latitude scale, what will happen to this if I measure it on the latitude scale? This will come as 46 minutes. So departure is the east-west distance when you measure it on the latitude scale. If I need to find out the departure between any two longitudes on the chart, I just pick up my divider, put it between these longitudes and turn it around on the latitude scale. And the minutes of latitude that I get, that is my departure. Alright, so departure is the east-west distance on the chart measured on the latitude scale, because it is a distance. Departure is a distance, so it has to be measured on the latitude scale. Now what is DMP? Although this is showing 46 parts, 46 minutes, but DMP is actually the north-south distance. If I want to find the difference in meridional paths between 40 north and 46 north, I just turn around this north-south distance, put my dividers between these two latitudes and turn it on the longitude scale. Whatever reading I get on the longitude scale, that is my DMP between those two latitudes. For example, I want to find out the DMP between this and this. I just put my divider here like this, turn it around on the longitude scale. The minutes of longitude that I read, that is my DMP between these two latitudes. Okay, so meridional parts are how many minutes of longitude you can place between two latitudes, that is DMP between those two latitudes, or meridional part for any latitude. Suppose this is the equator and this is 40 north. So, and if you have a whatever longitude scale you've taken, so between equator and 40 north, how many minutes of longitude can be expressed? Because this scale is expanding up till 40 north, there will be a certain amount of minutes of longitude that you can place. Up till 50 north, there will be much more minutes of longitude that you can place. 60 north, there will be much more. So it is expanding. Okay, so if you want to find out the DMP between any two latitudes, you just put the divider, put it on the longitude scale, you will get how many minutes of longitude can be placed over here. So if I put my divider here and then turn it around like this, I can count the number of minutes of longitude. Suppose it comes as 15. So what is happening is, I am counting the number of minutes of longitude that is present between these two latitudes. Alright. So that is the basic idea of how to measure departure and DMP on a Mercator chart. Alright. So let's address a question, okay, and then we'll go about explaining how to construct a Mercator chart. Okay. So okay, let's see one question. Okay. The question says, construct a Mercator chart from 41 degrees north to 45 degrees north, or an area from 41 degrees north to 45 degrees north and 60 degrees east to 60 degrees east to 64 degrees west. So, oh sorry, 64 degrees east only. Yeah. Okay. To a natural scale of 1:1 lakh in latitude 43 degrees north. So to a natural scale of 1:1 million in latitude 43 degrees north. Okay. Now, yeah. So this is the question. Now there is a new word, natural scale, right? Okay. So what is, we have seen the longitudinal scale, longitude scale. We have seen the latitude scale, how it changes with latitude. Now there's something called natural scale. So in my last video, we had assumed a longitude scale. What was our assumption was 1 minute of longitude is 1 centimeter. And we can very well construct a chart with that scale. 1 minute of longitude is 1 centimeter, and we constructed a chart. No problems over there. But now we are given a natural scale. So what is a natural? A natural scale is how many units on the surface of the earth can be represented by 1 unit on the chart. So 1 centimeter on the chart is how many centimeters on the earth, on the actual earth. So, and it defines how much area can you put on the chart. So natural scale is given because how much area you want to cover. So suppose this is my chart. This is generally the nautical charts are of a standard size. So how much area you want to cover on that chart, that is defined by that natural scale. Okay. So 1 is to 10,000,000. What it means is that 1 centimeter on the chart is equal to 10,000,000 centimeters on the earth. All right. So in the last in our last assumption, what we had taken was that longitude scale is 1 minute of longitude is equal to 1 centimeter. All right. And we had taken a longitude scale at the equator. Okay. So here 1 mile, the latitude scale and longitude scale is same. So 1 mile over here is 1 minute of latitude and 1 minute of longitude. All right. And when we were constructing here at 40 degrees north, what happened? That 1 mile was not 1 centimeter. That 1 mile has become 1.3 centimeters over here because that latitude scale has expanded. All right. So on the equator, in our last assumption, what would be the natural scale? You can assume the longitude scale first and come down to the natural scale, or you can have a natural scale first and derive your longitude scale from the natural scale. You can do it both ways. Okay, but by assuming a longitude scale, you don't know how big or small or how much area you're going to cover. By having a natural scale, you can figure out how much, what will be the distance between the end points of the chart. Okay. So here if you see, what is the longitude scale? 1 mile of longitude is 1 centimeter. So what would be the natural scale? 1 mile of longitude is still 1 mile. So 1 centimeter is equal to 1 nautical mile, and 1 nautical mile is your 1852 meters, right? And you multiply it by 100 into some terms of centimeters, you will get 1 centimeter on chart will measure 185200 centimeters on earth. Okay, so we assumed the longitude scale last time, and we can figure out what will be the natural scale. This will be the natural scale. All right. So now if the natural scale is given to you, you can derive your longitudinal scale from that. All right. So, but you have to understand one thing. This natural scale is at the equator. If I have assumed 1 minute of longitude here as 1 centimeter, this is valid over here. So this natural scale is for this equator. So if I have to convert it to the natural scale at this latitude, I must find the departure at this latitude between that much of longitude. I must find that departure. All right.